Stay ಇದೆ तीन है, एक ऑनलाइन में, वो लड़की है। हाँ, और ऑफलाइन में तो कितना है?
Good evening, sir.
Hey, how are you? Nivan is online today.
Yes, sir.
What happened, boy? Not well?
Yeah, like I had fever 2 to 3 days ago, and still I have effects.
What cold and cough is it?
Yes, the cough is really bad right now. That's why.
Nowadays, I've copied your style, man. Early morning, get up and have some lukewarm water.
Right, it helps.
That's good for the throat and the health, is it? I feel.
Yeah.
That's great. So, how long you are cold and cough?
I have had this thing since Saturday.
Oh, now it is Wednesday. Quite a deal of our time is.
Yeah, it's bad.
That's okay. Okay, I think we were with the earthquakes. Am I correct? Or we
Yes.
are finished with the earthquakes. Just check in your notebook. I think I roughly remember we were almost closing the chapter. Your this friend is also not there. What's his name? Rudra hasn't joined. I don't know. At least attendance wise, you are more serious as compared to him. Check in the notebook because earthquakes.
The last thing we were doing was effects of earthquake.
That's right.
Yeah. So,
what is it?
the effects of the earthquake was the last thing we did. So yeah, there is still a bit left.
I remember positive and negative impact. Just check which impact did I get.
Just a second.
Positive and negative.
Oh, you didn't actually give any like effects of destructive or constructive.
I remember I had explained the both positive impact and the negative impact of earthquake. In fact, I had asked you to write it in your notebook. Am I correct?
Yes.
So after that, what is the next topic? Wait, I get the book. Because you only after that, what is the topic? I think that is with that the chapter coming to an end. Am I correct?
No, sir. Actually, there is like distribution of earthquake and predicting of earthquakes.
I'll give you. Okay, I'll give notes on that. Don't worry. So put the heading in your notebook. Nivan is present. The second boy. Nivani.
Yes, sir.
So put that heading. I'll give you. That is the last heading of the chapter. There are 3 belts. Is there 3 or 2 belts all over the world? How the earthquakes are distributed? Am I correct? Put the heading distribution of earthquakes. It is distribution. Distributed of. I'm writing EQ, but you write it fully. Yeah? So what is EQ stands here? Earthquakes. The Circum-Pacific Mountain Belt. Circum-Pacific Mountain Belt. Midward Mountain Belt. So mountain belt. In fact, there was a nice video. I don't know when you guys both join. I'll show you today. I'll just give you the notes. Okay. Don't write below because I'm going to give that. Second one, it is Midward Mountain Belt. It's Midward. Hey, keep your video on at least. What is it? Your net is Nivan?
Yes. Yes, sir. Sorry, sir. I was just coughing.
Keep your video on.
Yes.
At least I feel that a student is right in my sentence. So that at least I can see there. And after ये तेरा दोस्त तो नहीं आया है. So when you look at these three, now you tell me based on what they might have given you the meaning. Based on what? The names of the mountain. That's it. Atlantic ridge is not. Now, based on what the namings are done?
The way they are like placed in somewhere.
Look at the words, you'll understand. Circum-Pacific. We have Pacific area?
Yes.
Yeah. Now, if I want to tell you why do we need to classify the earthquakes, because already we have done types based on our origin. You remember origin? How many? Active, dormant, and extinct.
Yes.
Extinct, correct. Active anytime. Dormant means sleeping. And extinct for last 50 or 100 years, there is no volcano. But now here it is distributed. Accurate distribution. Now here it is distribution. It is based on the entire world, which are the areas where we are seeing the occurrence of the earthquakes. I would say this is circum-Pacific, and the word mountain. Generally on a mountainous area. Mid-world mountain belt is something on the latitude side. You understand the latitudes, is it? And the next one, it is mid-Atlantic. Atlantic, the area where we classify the Atlantic. Not mountain. It is ridges. You understand ridges? The raised area. So based on the place where it is found, based on the latitudinal extent where it is found, we are dividing the earthquakes into three. Come on, read. Looking at the board only.
The circum-Pacific mountain belt, the mid-world mountain belt, the mid-Atlantic ridge.
While writing in the exam, the confusion occurs between these two.
Yeah. It will be
how do you avoid? I'll tell you. This is mid-world mountain. This is a ridge. Here it is no Atlantic, no Pacific. Here we have Atlantic. So you remember the second one is mid-world mountain. The third one is mid-Atlantic. So remember this word and this word. It will separate it.
Okay.
Mid-world, mid-Atlantic. And this is a mountain and this is a ridge. So if you want, yes. Correct?
Yes.
So shall we write below the first one, circum-Pacific mountain belt?
Yes, sir.
Right in out of the total earthquakes, more than 70%. Of the earthquakes are found in this belt.
Can you repeat it, sir?
Out of the total earthquakes,
yes,
more than 70% of the earthquakes are found in this belt. More than 70%. More than 70% of the earthquakes are found in this belt. So can we say this is the total chunk? मतलब जितना भी world में है, this alone has maximum.
Yes.
Have you heard about Saint Andreas in America?
Yeah.
There was a lovely movie on Saint Andreas. Have you watched it?
No, but yeah.
The movie is little bit, movie है तो थोड़ा बहुत बड़ा चढ़ा कर दिखाया है. But in reality, if I show you the video, the Saint Andreas was one of the devastating earthquake in some part of America. So now they are looking at that point, Saint Andreas. Can you check there now? Online you will get it, Saint Andreas.
Yeah.
So write the second one, that is same heading. The Saint Andreas fault in USA. It's in California. Saint Andreas fault. Saint Andreas fault. US, California. Or California, US. So write CA US. Lies in this belt. Lies in this belt, which is highly prone to, PRONE, to EQ. What is EQ?
Earthquake.
You can write it here. The notebook you write, which is highly prone to earthquakes. Second, next point. Some areas of Japan, Philippines. Some people call us Philippines, is it? How do you pronounce?
I call it Philippines.
Oh, Philippines, you love it.
Yeah.
Some people, the citizens are called as Filipinos. You know who are they?
Yeah.
Have you met any Filipinos in your life?
And never.
I have met many.
Yeah, probably because of traveling.
The two good things about Filipinos, they are very good with their English.
Oh.
They are very good. You go to America also, these Philippines people are working all over the world. Because Philippines is a country which is full of nature, but the problem is full of nature, floods and earthquakes are very high. So
Yeah.
they are generally out of their country, and Philippines is a very less developed country. So I remember Singapore, $1, some Filipinos told me $1 of Singapore is equal to 150 baht or something. Philippine dollar ka 150. 1 is to 150. I remember I've seen certain people only working in Singapore for $800. So $800 is a very ordinary amount in Singapore, correct? Then he told me, sir, for this 800, it will be close to 80,000 in Philippines.
That's
So almost 1:10 or 1:100 ratio. So over the day, sir, $300 I spend here. I spend 500, send 500 to my Philippines. 500 will become 50,000 or more than that. So there's $800 is a big amount for them. For example, ours were close to $4,800 or $5,000. उसमें भी हमको महंगा पड़ता था.
Yeah.
$800, $900 में करते क्या है? So Philippines is a country which is very beautiful. Nature. But the problem, the floods, earthquakes, volcanoes नहीं है मेरे ख्याल से, but floods and earthquakes are very frequent.
Yeah.
Correct? Write down Japan, Philippines, and Indonesia. Okay, that's it. Then you can go down to second, write mid-world mountain belt. Mid-world mountain belt. Mid-world mountain belt, the second heading.
Yes, sir.
All right, first point. It stretches from Eastern Europe. Bracket you write Alpine Himalayan ranges. It stretches from Eastern Europe, Alpine. Hey, where is this Alpine area?
I don't remember where the Alpine is actually.
Tundra vegetation suna hai? Tundra and taiga, America and Canada. Very cold. These are those areas, Alpines.
Oh.
Right? So look at the stretch from Alpine to Himalayan ranges. Next point. It contributes, or this belt contributes only 20% of the earthquakes. Contributes only 20% of the earthquakes. Bus. Then go to the mid-Atlantic. Mid-Atlantic. Includes the mid-oceanic ridges. Mid-oceanic. You understand oceanic? In between the ocean, the ridges. Land stretching into the ocean. Have you heard about this Grand Canyon of New Zealand?
Yes, I think so. No. Not of the New Zealand. No, not of New Zealand.
No, I'm so sorry. Not of New Zealand. This is Australia.
Oh, that's all.
Grand Canyon of Australia, a huge landmass which is deep into the ocean. It's called the ridges, which is found not exactly in between the ocean. मतलब एक land से लेके ocean का एक part तक जाता है, correct? More or like a ridges. Right down. Mid-oceanic ridges as well as many islands. Near the Atlantic Ocean. Near the Atlantic Ocean. Full stop. Remaining 10% of the earthquakes. You remember 70, 20, 90, and the rest 10% is from here. Remaining 10% of the earthquakes. Are from this belt. Remaining 10% of the earthquakes are from this belt. Now we read all these three and then tell me. There is one more point. The Rift Valley of East Africa. Next point. The Rift Valley of East Africa is extension of this belt. The Rift Valley of East Africa is extension of this belt. The Rift Valley of East Africa, extension of this belt. Read all the three and tell me, is it quite okay? Because not a detailed question, but then they might ask you.
Okay, sir.
I'm just bringing a video so that you understand. San Andreas, you must watch. It's a nice movie, but then you will understand more detail because you must look where it is closely located. It becomes easy for you to understand. I hope this is a better. Hey, your school exams got over, boy?
Yes, sir.
And the papers marks?
Oh yeah, I got my geography marks like yesterday.
How much, man? How much it is?
I got 41 out of 50. It's actually pretty good because the way I looked at everybody's paper, yeah, it was actually very good.
But next time try to be 45, 46, something like that.
Yeah, next time I'm gonna go for 50.
Okay, but you want me to discuss any part of the question paper or anything, something like that?
The thing is, I actually didn't go to school yesterday. I got to know it from my friend.
Okay,
so,
next time when you are physically coming here and if you get the paper, so that if you have any queries or anything, I can help you in solving that. Okay.
Yes, sir. Yes, sir.
In fact, this is a movie scene, San Andreas only. So you will understand the classification in a much better way. Let me put here. Are you saying the plate tectonics, distribution of active volcanoes and earthquakes, major mountains? You're getting the noise volume?
No, sir.
Then welcome. In this video,
now I'm getting
and relate the distribution of active.
This is volcano.
Theory. Previously, you learned that the Earth's crust is divided into plates. Now let's take a look at these lessons. Let's start with Lesson 1, Distribution of Earthquake Epicenters in the World. Earthquakes are vibrations caused by rock breaking under stress. Every day, millions of tiny earthquakes happen, but we can only feel those who are strong enough. Now, how are earthquakes distributed in the world, and how are they related with plate tectonics? Let's take a look at this picture showing the distribution of earthquakes around the world. The red dots represent the location of earthquakes' epicenters. What do you notice? Before we discuss this, let's ponder on this simple activity and try to answer the questions that follow. If we have the map of the lithospheric plates and place the map of earthquake epicenters on it, what do you observe? Now pause the video for a moment, get a paper and try to answer the following questions. 1. How are earthquakes distributed in the world? Number 2. Where are they located? And number 3, why is it important for us to identify areas which are prone to earthquakes? One of the evidences of plate tectonics is the distribution of earthquake epicenters in the world. In here, the yellow dots represent the earthquakes. As you can see, earthquakes are not randomly distributed in the world. They tend to occur in the boundaries of each lithospheric plates. Countries along the plate boundaries experience over 1,000 earthquakes yearly. Philippines, for example, is located in one of the most active tectonic settings in Asia. Earthquakes in the Philippines occur along the Philippine Trench, the Manila Trench, the Philippine Fault Zone, and the Valley Fault System. The Philippine Trench, the primary source of earthquakes, was built by subduction of the western edge of the Philippine Plate beneath the Eurasian Plate. This trench extends from south of the Mindanao Island to the Luzon Island in the north. Several numbers of destructive earthquakes have occurred in every part of the country. The Central Luzon earthquake in 1990 with a magnitude of 7.6 was the largest seismic event in the Philippines. Not all earthquakes occur at plate boundaries. There are interplate earthquakes that occur because of the stress in rocks being released. This is what caused the 1968 Meckering earthquake that happens in Western Australia, which has a magnitude of 6.8. This caused major damage in structure and infrastructures. Scientists are researching on ways to predict the occurrence of earthquakes, but until now, there are no devices that can measure when or where an earthquake may occur. And that's the end of Lesson 1. Congratulations! Now let's discuss Lesson 2. Distribution of active volcanoes in
And this you don't know, does it?
are places on Earth
The
during
earthquakes.
the plates.
Volcanoes,
Comes from the word oros, which means is a group or chain of mountains located close together. Mountain belts often share the same geological origins. Mountain ranges have
Now you remember I was saying this mountain belt, correct?
Yeah.
This is the mountain belt which is showing the deep origins. For geological means long time period, nothing like.
similar form, size, and age. The process of mountain building is called orogeny. This comes from the word oros.
What is that orogeny is saying? It is the process of mountain building. It's a new word in geography. You can note it down in your notebook. Look at that. Orogeny. Oros means mountain. Genesis means creation. Make a note. So these are some lovely words in geography. If you're quite interested in maybe in future also, up till the 10th standard. The word is orogeny. The process. First you write orogeny, then you write below the process of mountain building. First you write orogeny, and then you write down the process of mountain building. Process of mountain building. And then you say it literally, no need to write it literally means, you write oros means mountain, genesis means creation. After this distribution is done, and this chapter is coming to an end. The next chapter is weathering. But you should remember.
Yes, sir.
Done? Let me play the video.
Yeah.
which means mountain in Genesis means creation. Now let's study this illustration showing the map of the major mountain belts in the world. Areas shaded with red are places on Earth where mountain ranges are located. What do you notice? Before we discuss this, let's ponder on this simple activity and try to answer the questions that follow. Let's have first the map of the lithospheric plates and place the map of the major mountain belts on it.
So now look here, whatever we have written, Philippines is there, Fiji is there. Are you seeing? The North American is there, Appalachian is there. These now he is explaining the plates. Did you see Australian plate?
Yeah.
Exactly above Australian, we have a plate called Eurasian. He's trying to explain the plate and its movement. Then he will be bringing it to where all the earthquakes located.
Study the map carefully and answer the following questions.
Just forward this.
Number 1, what? And number 2, how will you relate the distribution of mountain ranges with the distribution of earthquakes and volcanoes? The Earth's major orogenic belts are the Circum-Pacific and the Alpine.
Did we do the first one? Circum-Pacific belt. Are you seeing it? Look at that. Areas, Japan is there, Philippines is there. I don't know. Then East Pacific rise is there. This North American Cordilleran is there. And then if you look at that Alpine region, did I not say the Circum-Pacific Alpine Himalayan?
Yeah.
Look at that orogenic belts. What is orogenic? These earthquakes have happened because the formation of the earth, formation of the mountains.
Yeah.
So we say the present day major mountain is all thanks to the earthquakes.
Oh.
You remember the positive side, the constructive effect of the earthquakes.
Yeah.
So this Appalachian mountain has come all thanks to the earthquake which has happened.
Okay.
Correct?
Yes.
So at least you understand in a map where these belts are.
Himalayan orogenic belts. These are the major mountain building belts in the world. Mountain ranges are formed by a variety of geological processes, but most of the significant ones on Earth are the result of plate tectonics. Most mountain ranges have been formed at convergent boundaries where two plates move towards each other. Formation of major mountain belts in the world. Let's start with the formation of the Himalayan mountains. The Himalayas were formed when two continental plates collided. Indian plate moved towards the rest of Eurasian plate during.
Remember, I was explaining Himalaya. It is a young full mountain. Look at the years. It is only 70 million years. And the plates have moved away. Which plate? The African and the Eurasian. Europe and Asian plate together, they are saying Eurasian plate. So the Himalayas have rose to the prominence. Let's listen.
The last 70 million years. The leading edge of the Indian plate have been thrust beneath the edge of the Asian continent. In the collision zone, the Asia overrides India and is therefore uplifted and folded to form mountains.
What is that? Asia overrides India. The Asian plate has moved up. Correct. Since it has moved up, the low-lying area in that region has become rose to prominence. Are you understanding?
Yes.
Let my video also keep it on. Because look it. So when this Eurasian plate were moving away, the low-lying area has come to up. Might be the Eurasian plate has gone down. Correct. So the Asian has override the India. So Asian plate has made some part of the Indian plate rose above. Since it has rose above, we have the Himalayas. And then I remember telling you folding has taken place. And horizontal which movement? Upward movement.
Yes.
Correct.
Yes.
So there is a we can say collection of factors. Not only one factor has led to the formation of Himalayas, right?
Yeah.
Oh. The video.
Mount Everest of the Himalayan mountain is the tallest mountain in the world at a height of 8,848 meters.
So I always make the students to remember the height of the Everest is very simple. 8848. How do you remember?
8848.
What is it? 8848. MSL you have to write. What is here? They only written M, but in the exam if they ask you to write MSL. M mean height above sea level. MS.
Yes.
Right.
Up to this day, Indian plate is still moving and Himalayas are still growing. Formation of Andes Mountains. The Andes were formed when the Nazca Oceanic Plate moved towards.
We'll stop the video. I think Himalayas up till it's quite okay. At least you understood which are the belts we are seeing it in our studies. So generally, either the Circum-Pacific or the we can say Asian belt. So they have given rise to certain constructive factors and certain destructive. And San Andreas, if I show you the video, may not be today when you come down next week, it is a far more destructive plate what it was earlier. So San Andreas is considered the most destructive for CA. What is CA? California. California. All right. So let's proceed with the chapter. So you tell me the question answers. Distribution we have done, and there is a very small paragraph they've given predicting the earthquake. What is the meaning of the word predicting?
Like for a way to predict when the
What is the other word I can use, which is also used in geography? You write there forecasting. Forecasting climate cloud.
yeah.
You write on forecasting there in the volume. Forecasting. And start reading the line. I'll explain to you. From YouTube volume.
Earthquake prediction is the past. In the past was left to astrologers and mystics. Today it is a respectable scientific suit. The Russians were the first to discover P and S seismic waves in 1960s. On the basis of the predictions were made. The wave,
Predictions. You understand predictions?
huh?
Predictions. What are predictions?
Forecasting.
Like can occur. Are the geographers predicting on their own or there are some calculations?
Calculations.
Yes, very good. Go ahead.
The waves still are only means available. Seismologists.
What? Seismologists. Who are seismologists? Who study seismography. उधर नीचे लिखना. Who study seismography. What is seismography? Study of the earthquakes. This is the word. People who study seismography. This is the word. So they are called as seismologists. Next.
The theory of plate tectonics offers another means of prediction on scientific lines. Japanese use the method of measuring changes in sea level and variations in Earth's magnetic field to predict earthquakes. However, no method is still foolproof, as has been proved by recent earthquakes in Japan and India and the USA.
Quite recently,
Yeah, it was.
not major earthquakes. We had the last one was Latur in Maharashtra. Then we had Bhuj in Gujarat. So whatever method, like Japanese says, when the sea water is rising, it's a signal. But till now, there is no guaranteed method to measure that earthquake is going to come. We do not know. Maybe we have this Richter scale, and if the Richter scale is catching the, you remember three types of waves I told you: P waves, S waves, and L waves.
Yes.
Correct.
Hmm.
L waves. If the seismographers are able to catch those waves,
Hmm.
then we can predict. But there is no correct method to say that this time this area will get an earthquake. Is that okay? Now look at that number of earthquakes in India. Not in India, but also in different parts. You take Kolkata. 1737. I think much before the arrival of British. And again we'll go back in India again. Is it? Or no India? Is it? Again, that Gujarat. Are you seeing? Well.
Hmm.
And there we can have Bhuj in Gujarat. BHUJ. Bhuj. Look at that magnitude of the earthquake, 7.7. And how many people died? 18,000 close people. Correct?
Hmm.
And then how many India had? Nearly. Yeah, have you heard about this Haiti?
Hmm.
Haiti island. It's a very backward island in some part of Africa. And the entire island collapsed. It's a very bad earthquake. I remember, I don't know, 2010. Yeah, correct. 2010. Then Nepal, no need. Then Honshu, Japan, that's okay. There is a place in number 11, Taipei, Taiwan. Have you heard yesterday's news?
No.
America and China.
No. I didn't.
Taiwan. Today, Taiwan calls itself independent.
Oh.
They call themselves as independent democratic republic, but China doesn't accept. I
Oh.
remember some Olympics games earlier before Taiwan showed that we are independent. उसको उन लोगों का नाम कैसा डालता था वो कंट्री का नाम चाइनीज ताइफाई बट
Oh.
उसके पहले नाम आएगा चाइनीज.
अच्छा.
Taiwan is intelligently, brilliantly ahead with the technology, but it's a very small country as compared to China. Yesterday, that American, what is that, Lok Sabha speaker came. If you want to watch the news, is it?
No, I didn't.
Yesterday was in Washington, lecture only by in between the lecture, I told you, I keep watching the news. Suddenly, there was a news that China might attack Taiwan because that the speaker was landing from, I think, Malaysia. She
Yeah.
took a flight from Malaysia, she landed in Taiwan. Although China was getting all kinds of threats. And today she took a flight also. She went back to America.
Oh.
18 hours she was in Taiwan. And China was furious. So why I'm giving this story, you have to connect that to a place called Taipei. Taipei is the present China, present Taiwan only. So ये साथ में वो अपने आप को क्या बोलता है China, they used to call Chinese Taiwan. They never call Taiwan. The Taiwan is that present. Is it okay?
Yes.
Go to the next page. Things to remember in that you take down seismic focus. They might ask you what is seismic focus. Then pick up epicenter. Then you take fold and fault. Now do one thing, fold and fault you write in the notebook right now, looking at that. They might ask you and tell me if you have a query, I'll explain the difference between a fold and a fault. No need of a fault plane, but you write down fold and fault.
Yes, sir.
Question answer, then I can take you to the new class. You have good time. 15 is it? Let me pick up some other good videos if you have. By the time you finish writing, I'll show you that San Andreas. That's a devastating earthquake world. San Andreas. So we have a discovery clipping as well as the movie clipping. I'll show you the discovery clipping. San Andreas. You know, there is a person in WWF called Rock. You guys don't know?
Oh, yeah. Yeah.
He only, I think, produced and directed.
Oh,
And he's the main ruler. This is a discovery video, you'll understand. You finish it, then I'll play you San Andreas in California, US. It's a nice movie.
yes, sir. Done.
Done? Shall I play the video?
Yeah.
These are discovery videos.
These giant gashes in the Earth are reminders of our planet's awesome power. They are fault lines, fractures in the Earth's crust,
how deep is
where
the crater?
huge slabs of rock slowly grind past each other. Most faults we can't see, but here in California, the San Andreas Fault is visible at the surface.
You can't have an earthquake without a fault. And I'm standing right now on what is perhaps the most famous fault in the world, the San Andreas Fault, that extends from Mexico down south, way up to Oregon in the north. This is one of the few places in the world where you can stand with 1 foot on one tectonic plate and one on another. In other words, this ground here is attached to New York and Iceland. The ground here is attached to Hawaii and Japan.
The San Andreas Fault sits on the boundary between the North American and Pacific plates. It's called a strike-slip fault, a place where two plates collide and try to slip past each other. As these plates move or creep in different directions, sometimes they get stuck. The longer they stay stuck, the more tension builds and the bigger the eventual quake. In other places, the plates move smoothly past each other. These areas buckle as the Earth shifts. The changes are subtle. Roger Billam keeps track of these changes with his creep meter, a device that measures movement along the fault. A computer collects data every minute for a year. This jump in the graph tells him the Earth shifted about 5 millimeters in a couple of hours. A small shift like this can have huge consequences for us.
That might not seem much, 5 millimeters, but it's affecting a long section of the fault, maybe 5 miles long, involving millions of tons of rock. Now, it really doesn't matter here. This is a nice sort of field that aren't in people, but further north, this creep process and the things that are happening beneath the Earth are far more sinister.
The San Andreas Fault and its branches trigger more than 10,000 quakes a year. Sometimes the results are devastating. Just ask the people of Los Angeles or San Francisco. Over the last 2 decades, major quakes rocked both of these cities. Life goes on, but the risk remains. In an area this active, the next violent tremor could happen at any time.
You understood what is the presenter saying? Anytime the earthquake can occur. That is the danger of this area. You watch that video clipping of that movie, you'll understand how they were. Anytime the cracks begin, but then people live on as if nothing is going to happen. Correct?
Yeah.
But it's a wonderful one. You have to watch that way. At least you'll understand the intensity of this area. Have you seen it?
That is
Just, this is a movie is little bit hyped, but the reality is the same. The name of the movie is itself San Andreas. San Francisco, California. Look how the city is beautiful. You identify this fellow, is it? He's that fellow producing the thread.
they're okay.
Oh my god, look at the crater, how deep it is. You remember this bridge was shown earlier also in that original video?
Yeah.
That's the longest bridge in California.
Oh.
Get to the side of the stadium. To the side of the stadium right now. This building's gonna collapse. You need to move. Hurry! You gotta get off the street. Get to the side of the stadium right now. Side of the stadium. Get to the side of the stadium. Come on. Off the street. Get to the stadium. Side of the stadium. Come on. Get out of the street. It's all right. I got you. And up. Here. Take her out. Everybody down!
He only flies a chopper. Correct.
We're just gonna set it down right here.
So frightening boy. Why I'm showing this the movie video, because it has really caught certain things which was not shown reality. Because in the time when the earthquake was at a high, it was too difficult. But this movie has clearly explained how devastating is San Andreas. They say any kind of earthquakes click in, but then people are very positive. They keep working, keep doing everything. And this movie has really shown how the people of this California have got adjusted with this. Because nothing can run from the Mother Nature, is it? When comes and what comes, we do not know. But then face it. So now tell me any question answers from the same chapter, almost chapter is done. Now there are questions like what is seismograph? Correct. Then describe in detail effects of the earthquake. What is Richter scale? Out of the three, all the three questions you can attend. Are you sure?
Yes,
Then look
sir.
at the next question. What is a fault? Now only you have written in the book.
Hmm.
Then look at that. Describe the measurement of the earthquake. I think we have done a paragraph from the textbook as well as from the volume. How the earthquakes are. Two scales. Which are the two scales you remember? Richter scale and
Yeah.
Mercalli.
Yes, Mercalli.
Which is the most appropriate scale?
The Richter scale.
Mercalli is not so, but we
Yes.
use Richter scale. Correct. That's good. You have to write about that. So the chapter is done. Now you tell me. Before we start with the volcanoes, there are one or two chapters you asked me to skip. You want me to continue with that chapter? That is, I think the chapter is called rocks. Am I correct?
Yeah, I think only that chapter is left.
Is
Like
the
in
rocks
between.
going to come for the coming exam, or shall I proceed with the next chapter of earthquake? That is, if I'm not so wrong, the next chapter is weathering. Your school people have any given you any hint?
No, no.
So you want me to continue with weathering, or you want me to continue with rocks? Okay, you do one thing. By the time we meet for the next lecture, you cross check with your school teacher.
Yes, yes.
And then let me know. Now you do one thing. Pick up that answer sheet. This one worksheet.
Yes.
You can start the answer. Any two answers to solve it. Correct.
Yeah.
Because anyway, the other fellow is also missing today.
Hmm.
Correct. You start question number, I think, 3, in fact. You solve that. What I can give? What is Richter scale?
Yeah.
And I will show you that video for Richter and Mercalli scale also. Start solving looking at the textbook or volume. Scale related one.
Those numbers they tell you on TV, really. Hey everyone, thanks for watching the news today. I'm Trace. The ball was recently hit by.
And there's a video on the Richter scale. It's a discovery news only, so it's perfect. You can really rely on the news by discovery web people. And they are the best way to understand. Did you find the answer, boy?
Yes, sir.
So this is a video which is related to the Richter scale. Want to watch it?
Yeah.
Oh, quite interesting.
7.3 on the Richter scale, less than 3 weeks after being hit by a 7.8. The 7.8 destroyed buildings, killed thousands, and caused an avalanche. The 7.3 caused a panic and killed only a few dozen. Does 0.5 on the scale make that big a difference? Firstly, let me step back for a bit. When you describe a great dessert to a friend, you probably give it a rating. We humans love to rate things, but to truly rate it fairly, you'd have to understand the ingredients and the preparation, the plating, and the ideal dessert comparison, what you've just eaten prior, what you're drinking, where you're sitting, the temperature of the room you're in, even your mood at the time. Not to mention, whether you had a fight with your friend earlier that day, because that's going to all affect your rating. Science needs history, context, and tons of points of data, and that's just for a piece of cake. How can you turn all that data into one simple rating? Most people don't. They just measure how they feel about it at this moment. Like a layer cake, earthquakes are all different. When rocks are sliding, knocking, and buffeting against one another, they can slip, crack, jerk, and cause an earthquake.
So you see the two plates are coming together. And when it is coming together, look at the amount of shivering, correct?
Yeah.
Quake. But the friction and the fault line, the pressure, the depth, the type of rock, and the varied stressors of that rock's history all matter. To turn that into one number is actually a pretty crazy idea if you think about it. So the Richter scale was invented in the 19th.
Last time I told you, this is how the measurement, it is minus 500, minus, you see y-axis?
Yeah.
And then 500, 1000, these are the units. And look how it is going from 0 above and how it is coming below. Let's see. We'll explain.
1930s to give some understanding to the magnitude of a quake as measured by seismographs, ground monitoring equipment that's often used in earthquake measurement. It's logarithmic, so every 1 point on the scale is a 10-fold increase. So a 3 to a 4 on the Richter scale is 10-fold more powerful, and 3 to a 5 is 100-fold. Or to put it another way, a 7 is 10,000 times more powerful than a 3 on the Richter scale. The U.S. Geological Survey says that there are 1.4 million quakes that register above 2 every year, and only 16 that get a 7 or higher. But even after I've explained it to you, do you actually know what the Richter scale means? What does that number mean? Because I don't know. The Richter scale is only concerned about the amount of energy released by that single quake, and doesn't tell us much about what that quake did. Maybe it was a deep quake or away from a populated area. Maybe the quake was...
What is he saying? The Richter scale is trying to give you the amount of energy release. But how much is the destruction, the Richter scale will not tell you. Correct?
Yes.
So based on that only, that small pen-like thing, did you see? It is writing, not writing, sketching the lines.
Yes.
was under soft ground or in the middle of firm bedrock. All of that would change how that earthquake was experienced or how humans feel it. The Mercalli scale, or modified Mercalli scale, measures intensity of earthquakes. This is also used by the U.S. Geological Survey to understand how the earthquake...
You understand that word intensity, how deep it is.
Yes.
felt on the surface. The Mercalli scale was also developed in the 1930s, and it uses Roman numerals to determine how intense a quake is. They range from 1 to 12.
I think this is there in the textbook, correct? It is, the number is between 1 to 12, the Mercalli scale, correct?
Yeah.
Subjective. So, for example, a 2 is weak and, quote, felt only by a few persons at rest.
Can you please take a pic of this one, the right hand side? 1 means not felt, 2 to 3 weak. Are you getting it? So this is the Mercalli scale. You got a mobile with you, sir? Not of the person, but of that 1 to 12. Here they have given 11 to 12 is extreme. 9 is violent. These are the things you can add it to your answer when you're writing in your school. They might not understand what it is. What is number 6?
Strong.
Number 8?
It's severe. It's very strong.
Number 9?
It is violent.
Can we say San Andreas? Which number according to you? San Andreas, what you've seen the video?
It was probably extreme.
It is between 9 and 12. Am I correct?
Yes.
Now you understand what is the Mercalli scale.
Especially on upper floors of buildings. But a 6 is strong and, quote, felt by all. Many are frightened. Some heavy furniture is moved. A few instances of fallen plaster. Damage is slight. This is a measure of how it feels in an earthquake. It adds magnitude scale, which is a new measure for quakes. Moment magnitude allows scientists to use...
So this is a new scale which is not there for your syllabus. Look at the scale. It is moment magnitude. It is a computer model look at they are drawing the circles. The red circle means too many movement. Blue circle, less movement. And the green circle, the least movement. Are you seeing?
Yes.
So this also, if you want, you can note it down in your notebook. Moment magnitude scale. It's something new, which is not for your level, but then for a GK, you can keep it. Okay, so I can wind up this. So we have finished this chapter. Next time when we are meeting, you have to tell me either the chapter called weathering or the rocks. Whichever your school says, we will continue with it. Okay then?
Yes, sir.
Take care and hopefully I see you next time personally.
Yes, sir.
Okay, take care and bye.
Yeah, thank you, sir.
Okay.
हे बघा हे रेकॉर्डिंग चालू आहे का काय काय लाल बिंदी ही लाल बिंदी हा ही ठीक आहे हा आता बघा रेकॉर्डिंग स्टॉप होते